Welcome to the Missouri Wind and Solar Podcast. I'm your host, Wes Shank, coming to you from our store in Seymour, Missouri. Each week with my co-host and Missouri Wind and Solar's General Manager, David McDarris, we discuss the latest on self-reliant energy. Check out our additional educational information, including dates for our hands-on workshops conducted in Seymour, on our website, windandsolar.com. Thank you for listening to our podcast, and if you haven't already done so, please consider subscribing. Okay, I'm going to start today's podcast with a question for you. And Crystal usually sits in here with us quietly, so she may have to chime in on that. How long have we been selling the 3-PAL?
At least 7 years. At least.
You made a face.
Yeah, I might be able to look it up on eBay. Never dies.
No.
At least
we don't
7 years.
We don't want to talk about eBay.
Yeah, it's at least, with the current configuration, it's at least 7 years.
Okay. So we've had this out there for a long time.
Right.
And this is our bulk diversion charge controller.
Correct.
And this is a tried and true. This is a hammer in our toolkit. It hadn't changed in forever. It works every time it's tried, sort of thing.
Right.
However, there's the times they are a changing, right?
They've changed.
And so let's talk today in the podcast of where it might not be well advised to use the 3-PAL, right? You didn't get it's a podcast where you have to talk,
yeah,
right?
The 3-PAL was and still has its place in the charge controlling industry.
You might tell what the 3-PAL stands for.
The 3-PAL is
Okay.
3-PAL is basically a 3-in-1 charge controller. It can do wind and solar at the same time, which is still very hard on the market to find anything that will do wind and solar at the same time. But it can charge with wind and solar. It is primarily used in wind turbines. It is something that we had designed so that the turbine would constantly keep the turbine under load, which is a very big deal. You have to constantly keep your turbines under load. You can't let them go into free spin mode.
Or they basically just spin out of control, burn themselves up, and
they'll burn the bearings up is the number one thing.
Okay.
And they can cause how they burn up. The stator is not producing energy. It's because they get so hot that they actually melt the
copper wires.
Well, there's a coating.
Oh,
See,
yeah,
all the
yeah,
copper
yeah.
wires are just laid on top of each other, and they have basically a spray varnish, right? I mean, like a marine varnish, the same stuff that we do extra. If somebody is going to be like in a marine environment, they have a varnish that's put over them that keeps them from touching each other. And so if that gets too hot to the point of melting, then those wires now come in contact with each other, and then the phases short out, and they burn, and you've essentially burned up the unit.
So,
at that point.
But coming back from that rabbit hole,
yeah,
and it uses a mechanical relay, which is different because the other 99.999% of everything out there is using an electronic, correct? Right. And so this is, again, I'll say it is older technology, but it is tried and true technology. Right. Works every time you try it, sort of thing. Now, what has kind of been the proverbial fly in the ointment is lithium batteries. And so what's our problem here? What do we see happening first? So what's kind of the challenge?
Lithium batteries are very specific because of the BMS. And if you listen to the podcast, a previous podcast we had, the BMS battery management system, the BMS is rated for very strict parameters on voltage, on the high voltage side and on the low voltage side. So low voltage side shuts it down, says, I'm going to sleep. I'm not going to use any more. You can't do anything with me. Same way on the high side. If you try to overvolt that unit, it's going to say, nope, I'm going to kill all power coming into me because you could possibly damage my cells. So I'm going to shut you down. Not going to let that happen. On a wind turbine, especially, solar is not as much, but on a wind turbine, and that's what we're talking about right now is wind turbine and using the 3-PAL and using on lithium batteries. A wind turbine on a 3-PAL, you have a relay, a bank of resistors, and then you also have what's known as a rectifier, which our turbines produce 3-phase wild AC power, which can produce voltage from 0 volts up to 350 volts, and depending on the wind speed. And that's totally variable within just milliseconds of each other.
Yeah. Wind gust up,
wind gust up, boom. It's immediately. So the BMS cannot understand that. So if you just try to, so what happens is the rectifier. So you have your wind turbines producing 3-phase energy. It comes down the line as 3-phase energy, and then it hits this rectifier, which then takes the 3-phase wild AC and rectifies it down to single-phase DC. Okay, so just positive, negative, single-phase DC. And that's done through a bunch of blocking diodes and different parameters of different things of that. And then so that all happens, it comes down, and then it goes into the battery bank. Okay, so flooded lead acid batteries, not a big deal. They can take extreme
right. So we're coming back to just, again, it's the older technology. It can take whatever you can dish out. As long as you don't see a cap of it blow off and hit the ceiling, you're probably okay, right?
Right. And so, yeah, that's exactly right. So then lithium came to the market. Well, there again, lithium has, with this BMSs, has got very tight charging parameters as far as the low voltage and the high voltage. And that 3-PAL, when it comes to that rectifier, the voltage is not being changed. A lot of people want to think that that's where it's being changed over to 12 volt, 24 volt, 48 volt. The rectifier has nothing to do with that. You can just take the voltage out of your head right there. It has nothing to do with the voltage. All it is doing is rectifying wild AC power, 3-phase, down to single-phase DC. That's the only thing.
And that's whatever DC is coming out of there. It's
coming in at 200 volts wild AC, it's coming out 200 volts DC. It's just, that's what it's coming out. It's not, when all the conversions are done, when both legs are produced and everything's done, it's coming out and the voltage did not change. So if your 48 volt simplified batteries say, okay, my high side is 59 volts. That's the most I can ever let you put in me. And it's coming in 200 volts. It said, nay, not going to happen. I'm going to shut down. And so now you've lost your battery. And so nothing is even telling the controller to be on at this point. And now your wind turbine goes into free spin mode. And so not only do you take a chance on damaging the battery.
Right. It's just, you're assuming that the battery can kill itself fast enough.
Yeah. You're assuming that the battery. Now then you're also going to destroy your wind turbine because you don't have a battery bank that it's going to. So that's the reason we just won't. We won't sell it.
And understanding the reason why, and this is a financial proposition. The 3-PAL is very cost effective in comparison to something that has really even like a PWM or for that matter. It's still.
And right now in the wind turbines, we only have 2 options. If you have the AGM or the flooded lead acid, you can use the 3-PAL system. And it works. It's still not the most efficient way of charging.
And what are we talking about dollar-wise? What's
$350.
Okay. Versus
$1,999.
Okay.
And that's going to be on the classic VRD that's going to go through a classic MPPT controller, which is you're going to be able to set your parameters on your charging parameters specifically for the battery that you have. And it's going to do not really a dynamic braking system, but in essence, it's putting excessive load on the turbine if need be. And it's also going to give you the capability of charging your batteries at 99% efficiency and get the most energy out of the wind turbine.
And I think it's important to note here, we're talking about the 3-PAL, and we commonly refer to it as a VRD. The important thing to note here is VRD stands for voltage reducing device. And so that's what we're doing. An example you're just giving, if it's coming in at 200 volts, which would cook the Simplify battery is at least $2,500 somewhere in that range. Rather than cook that battery, we're reducing it. Where the 3-PAL is not going to do that, and you can't do that. Even though the battery might sense it, and
it might, you might get away and it just shut. But then you're just going to more than likely even with this gust of wind, you're just constantly being shut down. You constantly have to wake the battery back up and tell it to wake back up, and then hope that the gust of wind doesn't happen. Just as soon as you've done that.
And chances are, if it's gusting now, it's gusting later.
It's gust later, and it's just not a viable option that we're not even willing to really sell it with it. If we know that you have lithium batteries, we're not going to sell you.
So
that type of controller.
So the takeaway here is you need the right board to go with your batteries. I mean, and trying to think that you can get around and go with a less expensive option just because it's less expensive is incredibly short-sighted.
Right. Yeah. Yeah. I mean, I'm not saying that you bought a Simplify and spent $2,500, but let's just say that you bought a Battleborn or an Ames lithium battery. More likely, you gave anywhere from $800 to $1,000 for this lithium battery.
Yeah.
I mean, and more likely, if that's the case, you've also had to buy, in most cases, either anywhere from 2 to 4 of these batteries at minimum, just to series together to get to your 48 volt, because they don't do 48. I mean, if they do, it's going to be back to that $2,500 to $3,000 range. Just thinking you're going to save a buck by, buying that cheaper controller in the long run is going to wind up costing you $3,000, because you destroyed a $3,000 battery.
And as sad as it would be for us, you get to buy it again.
You get to buy it again.
We don't ever enjoy that. Yeah. That's never a
because it's a bad phone call. It's people are frustrated, and we get it. I mean, you're frustrated because you've lost your battery, and that's why all of our technicians here know that they just do not sell that controller with a lithium battery bank. So when they ask you, if you were to call in on the phone, if you're a new caller or new listener, you were to call on the phone, talk to them, one of the first things they're going to ask you, what type of, if you start talking about wind, especially, they're going to ask you what type of battery bank you currently have or are thinking about going with. And that will immediately set them into how they're going to design your system. If you don't have a system, currently and looking to get into one.
Okay. All right. Thanks for checking us out and appreciate you tuning in today. Thank you for downloading and listening to the podcast today. If you have a question you'd like to hear us discuss on the podcast or just want to say hello, email us at radio@windandsolar.com. As always, check out our store at windandsolar.com and buy some stuff. Your financial support underwrites our educational outreach, like the podcast, YouTube channel, and local STEM collaboration. It also keeps Lucy and her doggy chicken treats. Thanks again for listening.